Question 7. The circle C has equation x squared plus y squared minus 10x plus 4y plus 11 is equal to 0. Find the coordinates of the centre and the exact radius of C, giving your answer as a simplified surd. Okay, so we're starting with our circle equation, x squared plus y squared minus 10x plus 4y plus 11. Now the simplest way in which you can have a circle equation written is with the square completed. So we're going to complete the square for both the x and the y. So in terms of x, inside the bracket we're going to have x minus 5 because we are halving the coefficient of x. So x minus 5 all squared. Remember to subtract that extra 25 we're going to get. And then for the y plus half of the y coefficient, so y plus 2 all squared, subtracting the extra 4 that we're going to get, plus 11 is equal to 0. Simplifying this by adding the 25 and the 4 to the right hand side and subtracting the 11, you've got x minus 5 all squared plus y plus 2 all squared is equal to 18. Now when we have our circle written in this form, we can see straight away that the centre coordinates are solving these two brackets. So x is equal to 5 and y is equal to minus 2. So the coordinate 5 minus 2 is going to be the centre, and this is equal to r squared. So our radius is going to be the square root of 18, which is the same as 3 root 2. The line L has equation y is equal to 3x plus k, where k is a constant. Given that L is a tangent to C, part B wants us to find the possible values of k, giving our answer as simplified surds. So we've got this y is equal to 3x plus k. So this is the equation of a straight line. While not compulsory, I would advise a little sketch so you have a rough idea of what's going on here. Now I know the centre of my circle to be 5 minus 2, and I know my radius to be 3 root 2, so I know it to be less than 5, so this circle isn't going to cross my y-axis. Now my line 3x plus k, I know to have a gradient of 3, so I can roughly sketch two lines. These are the two possible lines which could be tangents to my circle C. So you'll notice one touches on this top edge and one on this bottom. So there are two possible values of k to find. Now I have the equation of my circle, x squared plus y squared minus 10x plus 4y plus 11. I have simultaneous equations here. So let's substitute y as 3x plus k into my circle equation. Putting y into this equation gives me x squared plus y squared, 3x plus k all squared, minus 10x plus 4 lots of 3x plus k plus 11. Expanding the brackets here gives me x squared plus 9x squared plus 6xk plus k squared minus 10x, and then expanding these brackets, plus 12x plus 4k plus 11 is 0. Now, writing this as a quadratic, so I have 10x squareds. My coefficients of x are 6k plus 2, and my numerical components are k squared plus 4k plus 11. Since these lines touch the circle in one point, we know the discriminant b squared minus 4ac to be equal to 0. So in this case my b is 6k plus 2, a is 10, and c is k squared plus 4k plus 11. So b squared minus 4ac is written 6k plus 2 all squared minus 4 times 10 times k squared plus 4k plus 11. Again, being careful when expanding the brackets, that's 36k squared plus 24k plus 4 minus 40k squared minus 160k minus 440. which is equal to 0. So rearranging this gives me minus 4k squared minus 136k minus 436. Now I'll show you how to find this on a calculator right now. So we can look at solving this quadratic on our calculator. So again, if we go to menu, scroll down to equations and functions, we have a polynomial of degree 2. We have minus 4x squared minus 136k and minus 436, and that's equal to 0. And our two values of k are given as minus 17 plus 6 root 5 and minus 17 minus 6 root 5. And as we've seen, our two values of k are minus 17 plus 6 root 5 and minus 17 minus 6 root 5.